right, so this lesson is 8.6 properties of logarithms. We're first going to go off by solving them, and then we're going to talk about the actual properties that you're witnessing. So the first set right here, we have a log with base 2 of 8 plus log of base 2 of 4. Well, if we know our bases are 2, well, 8 and 4 also can have bases of 2. So we can rewrite these. So this is going to be log of 2, base 2, 2 to the third, because 2 to the third is the same thing as 8, plus log base 2 and 2, 2 squared. So we know those are rewritten, and we have those figured out. We know how to do those. So what we can see here is log 2 and 2 means this is a 3. Log 2 and 2 means this is a 2 because it's our leftovers, and there's a plus here. So what's 3 plus 2? 5. Our answer is 5. So we're going to start to see the properties, and then I will do a generalization of them, and then you'll realize why we're doing this way with the generalization, and then we're going to solve them. Okay. All right, well, our next one, log base 2 of an unknown equals 5. Well, we know that to figure out this one, this is the same thing as just saying 2 to the 5th, which is the answer of 32. Okay. So again, that should be just a general review, and you'll see again why we're going through these. Again, if you could have figured it out, try and do these on your own, and then check your answers with me as you go through the video. So go ahead and pause, take a minute or two, see if you can figure out the rest of them up till where it says product rule. I think a lot of you have figured it out in general, and then we can talk about it later. But moving on, our next problem, log base 3 of 27 plus log base 3 of 3. Well, 27 is the same thing as saying log 3 of 3 to the third. And we don't need to change this one because it's the same thing. That's nice. But remember, there is an invisible 1 there. So we got to remember that does exist. So this will cancel out, and we're left with 3. This will cancel out, and we're left with 1. So we can see that 3 plus 1 is going to give us our answer of 4. Starting to see a pattern yet? Same thing goes for this one. Follows the same idea. If we have log base 3 of some unknown and it equals 4, well, what's 3 to the 4th? Well, 3 to the 4th is 81. So that's our missing answer. See? So remember, base 3 to the 4th is going to have to equal that. Well, this is properties of addition, and we're still working on some exponent rules here. We'll see what happens there. So as we're moving on to subtraction, it works the exact same way. Well, we have a base of 4 and 4. 16 can have a base of 4, and 64 can have a base of 4. So we can rewrite these as log 4, 4 squared, and log 4, 4 to the third. There's still a subtraction sign there. These are going to cancel. We're going to be left with 2. These are going to be canceled, and we're going to be left with 3. So we have 2 minus 3. So 2 minus 3 is going to give us an answer of -1. Are we starting to figure some things out? The properties will be entertaining. So, once again, we're continuing with those going from logarithm to an exponential. So we know we should have 4 to the exponent of -1. So you have to remember what negatives mean and what negatives mean. They mean fractions. So we know log 4 of 1/4 has to equal -1. So these should hopefully are being a quick reminder. Again, you can always go ahead and fast forward the video if you need to and go straight to properties, but please make sure you are doing the notes so that way you are having repetition for your homework. All right, so go ahead again. If you feel confident now, please take a moment to pause this video and figure out the rest of the problems by yourself. All right. So it looks like this is the last of our stuff. So we have another subtraction. Subtraction, same thing. We have an invisible base 10 on both of these. So we can rewrite these as log 10, 1,000 is 10 to the third, minus log, again, it can be invisible, you don't have to write these down, log 10, 10 squared. So this is the same thing as saying 3 minus 2, which means it's 1. Woo. Well, knowing invisible bases mean 10, 10 to the first, it's gonna have to be what? 10. Moving on to our last 3. We gotta figure out what in the world is going on here. So what we can see here is, again, log 5 is 5. That should be review. Our answer should be 3. Okay, remember that. As long as you have log base 5 with another base of 5, they have to match. You got it. Well, if that's the case, what's log base 5 of 5? It cancels, it's 1, right? There's a 3 in front. So it's 3 times 1? 3. Well, we have to manipulate this one because it's not 4 and 4. But we know 16 can be a 4. So we can manipulate this to be log 4, 4 squared, all squared, right? 16 is the same thing as 4 squared. Knowing, hopefully power to a power rule, this is the same thing as saying log 4, 4 to the 4th. Because 2 times 2. Power rule says we have to multiply our exponents. If that's the case, we now have log base 4 with the 4. And our answer has to be 4. Well, it's starting to look a little bit similar. We have a 2 times log base 4 of 16. Kind of looks similar to the other problem. So we have 2 times log. We want to manipulate 16 to have a base of 4 too. This will go away. We have 2 times 2, which means it's a 4. We're seeing the pattern here. So once again, just as a quick reminder, if you have same base and a base, your answer is your exponent. Okay? Has to be 4. Here's a new one. 3 to the, so this is an exponent, log of 3 to the 9th. Well, 3 to the log of 3 actually cancels itself out. 3 log of 3 will cancel out, and you're left with, once again, your answer of 9. If you have any questions, please feel free to meet me in our Zoom meetings on Monday. And if not, email me anytime. I will get to you. So we just kind of went through the generics of the properties, and we're going to go into the generalizations of the next. So that way you have a formula that works with everything we just looked at. So if anything, please make sure you have the formulas written down so that way you can refer back to them later. So our first rule, it's the product rule. Product rule states that any log of base b x plus log of base b, so they have to be the same, y is the exact same thing as saying log base b, so they change together, but we multiply them. It says product. Okay? So x times y. So we can combine those together. So if you remember from our previous one, if you would have done the first one of log 2 8 plus log 2 of 4, you would have taken 8 times 4, and you would have gotten 32. So we would have had log 2 to 32. So if we had log 2 to the 32, isn't that the same thing as 2 to the 5th? And our answer was 5. rule is very similar. You have log of a base with x minus log same base of y. This states I can transform it to be log of the same base, your first one, divided by this one. Could you go back to the other ones and see if that works? Taking those numbers? Let's say we took the example log 1000 minus log 100. We said the answer was 1. Well, let's look at this one. Let's use the same thing. So we take log, same basis. This means log of 1000 divided by 100. What's 1000 divided by 100? Log of 10. And we said log of 10 to the 10 is 1. So it's the same answer. Properties of logarithms. Our next one is the power rule. Power rule states that log of any base x to an exponent of y is the exact same thing as moving the y to be in front of log with the same base of x. So the y moves in front of the log. And then we have cancellation properties. There are 2 cancellation properties. Of these 2 cancellation properties, you have seen one all the time. The other one was that one with where we had an answer of 9. So the cancellation problems, when you look at it, you have log of a base with the same base to an exponent means it equals the exponent, because this stuff cancels, and we're left with our exponent as our answer. The other one states base with an exponent of log of the same base of n will still equal n, because this cancels itself out. Well, this is the beginning of 8.6 properties. We have just started by looking at a simplified version of the properties and our generalizations. So now we're going to get specifically into our notes. So our notes are going to be just a moment. Go ahead and take a moment to take a breather, take a break, and we will get started in just a second. So again, we are starting with 8.6, and now we're going to look at how do I condense and expand